Hello again. We're still in Chapter 1 of Geometry, now problem number 95. I'm actually going to do 96 at the same time. Problem number 96 asks you to find the area of each of the rectangles that we create in problem number 95. So might as well just do them at the same time. So Lord is, whatever the person's name is, I don't know, Lordy's, whatever, has created the following challenge for you. She has given you 3 of the 4 points necessary to determine a rectangle on a graph. She wants you to find the points that complete each of the rectangles below. Okay, well, obviously she doesn't know that we're awesome at geometry, and this is a very little challenge to us. So, we got 3 points. We want to find the 4th. We all know what a rectangle looks like, and so as long as we have 3 points, we can figure out where the 4th one's going to be. In order to do this, I'm going to draw a horrible line. Now I'm going to sketch out a graph here of where the points would be, just so I can visually see it. I know you can probably see this in our head, but just to make it easier, we'll put it down here on paper. So, -1, 3. So -1, 3, somewhere around there. -1, 2. So somewhere around there. 9, 2. So somewhere around there, which means the 4th point has to be at 9, 3. Okay, so the 4th point is located at 9, 3. Now to find the area, we're just going to find the length and the width of this particular rectangle. Well, the width here is just 1, right, difference between 2 and 3. And the length here, the difference between -1 and 9, is 10. So the area is 10 times 1, or 10. So the area is 10, location of the 4th point is 9, 3. Okay, same thing here for part B. Let's rough sketch it out here. 3, 7. So 3, 7 somewhere up here. 5, 7. So that's somewhere down there. Oops, put it over a little bit. 3, 7. 5, 7. 5, -3, so it's going down, so that means our 4th point has to be at 3, -3. Right there. So now to find the length and the width. Well, the length here, width here, whichever you want to describe it as, is the difference between 3 and 5, which is 2, and the difference between 7 and -3 is 10, so the area of this rectangle is 2 times 10, or 20. So area of 20, points located at 3, -3. Okay, on to the next set. We got C and D here. So again, we'll make just a rough little sketch. -5, -5 is somewhere down here. -5, -5. 1, 4 is up here. 4, 2 is here. So this one isn't nice and horizontal or vertical like the other ones. It's a little bit at an angle here. So something like this. Okay, so our 4th point is down here somewhere. And instead of just eyeballing it and saying, oh, well, it looks like it's around -2, -7, or something like that, instead of eyeballing it, we can actually figure out its exact location. If we can find the slope between these 2 points here, we know it's going to be the same slope between these 2 points here, because in a rectangle they have to sit parallel, so they have to have the same slope. So this was the point 1, 4, and this was the point 4, 2. So the horizontal distance there is 3, and the vertical distance is 2, so over 3, down 2. So same thing here. If we're starting at the point -5, -5, we're going to go over 3, which would take us to -2, and down 2, which would take us to -7. So it looks like -2, -7 is the location of that 4th point there. Now to find the area, we're going to have to find the length of these couple sides here. And to do that, we're going to need the Pythagorean theorem. So I'm going to use the Pythagorean theorem to find the lengths of those sides. We could use the subtraction method and take the whole rectangle and cut off stuff, but we're going to assume we know what's going on with the Pythagorean theorem here. So this part x represents these ends here, x, x. So we already know that this was 3 and this was 2, so 2 squared plus 3 squared equals x squared. 4 plus 9 equals x squared. 13 equals x squared. So one of those side lengths is the square root of 13. Now the other one will be a little more difficult to find, so we got to find the sides of this triangle here, which I'll redraw over here. So the horizontal distance is the distance from -5 to 1. Well, that's 6. The vertical distance is from -5 to 4, which is 9. So we have 6 squared plus 9 squared equals, we'll call that y squared. So 36 plus 81 equals y squared. 36 plus 81 is 117, so y equals the square root of 117. So the area of this rectangle is the square root of 13 times the square root of 117. Let's see if that reduces nicely. So 13 times 117 is 1,521, which actually works out really, really nice to be 39. So messy numbers, but ended up working out nice. And the last one here. So -52, 73. So there's -52, there's 73, so somewhere about there. 96, over 96, up 73, somewhere there. And then over 96, the scale is, I messed that up, so 1,483 is above 73. We can kind of see how it's going to look here. This fourth point is going to be at -53, and then up 1,483. So that's the location of our fourth point. Now for the distances here, so the horizontal distance is from -52 all the way over to 96. So 52 plus 96 is 148. And our vertical distance here is from 73 up to 1,483. So 1,483 minus 73 gives a vertical change of 1,410. My sense of scale here in this problem was off, but we'll go by the numbers, not the way I drew it. So the area is going to be 148 times 1,410, which works out to be an area of 208,680. So using the points, we can find the distance between those points horizontally and vertically to find the dimensions of the rectangle in order to find the area. And once we knew 3 points, it was easy to find the fourth point, since we knew it just had to be a combination. If it was a perfectly horizontal or vertical rectangle, this had to be a combination of those x and y values. In part C, it was a little more difficult because it wasn't a perfectly horizontal or vertical rectangle, but we're still able to find the coordinates based on using the slope between 2 points. We know it had to be the same as the slope between the 2 additional points. If you have any questions or comments, please feel free to leave a comment in the section.